Hello, everyone. Great to be here in Poland. First time I've been in Poland, so this is great. So yes, my talk. So a little bit of a warning. I've got 127 slides to get through in 20 minutes. So I'm going to talk fairly quickly. So yes, Spiderman's Uncle Ben and his advice for casting your WebRTC. So a little bit about me very, very quickly. I'm Dan Jenkins, founder of Everycast Labs and Nimble Ape. I'm also the creator of a conference called ComCon, which you might have heard about today a couple of times. And I was the first Google developer expert in WebRTC. I love Lego, I love real-time media, I love developing things for the web. Has nothing to do with Spider-Man. And I haven't seen the latest Spider-Man movie, and there's my social media stuff. So Everycast Labs, we have a product called Broadcast Bridge that uses WebRTC heavily. Nimble Ape is a consultancy firm, so got a problem with real-time media, and you'd like some help with it, let us know. And then ComCon is a residential event in the UK, so everyone stays in the same hotel for 3 days. Well, it's more like 4 and a bit. Top quality production values, 5 years worth of content on YouTube. And we're currently looking for sponsorship for 2024. So, public service announcement. All the images in this presentation were generated by Bing Image Creator. And yes, we don't have anything to fear from AI. AI will not destroy us. You'll see why. So yes, Spider-Man's Uncle Ben and his advice for casting your WebRTC. So remember, with great power comes great responsibility. Quite a few people attribute this to Spider-Man, Peter Parker, but it was actually Uncle Ben. And Uncle Ben was absolutely right. With great power comes great responsibility. So I'm going to assume that you all have a basic understanding of what WebRTC is, because we've heard about it quite a bit this morning and going into this afternoon. But a little history lesson first. May 2011, Google open sourced WebRTC. It was on the verge of being in June. Like the mailing list says the 1st of June, but it was actually in the last minutes of May 2011. What they really open sourced was libWebRTC and everything that kind of encompassed the beginnings of WebRTC. So libWebRTC is used by all of the browsers, and it mostly, because the browsers all use it in mostly the same way, everything just works magically. And as a result, we get nice W3C APIs that are built on top of libWebRTC. So we get user media, new media stream, RTC peer connection, create offer, create answer, blah, 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 right? These are all the ways that you can kind of start interacting with creating a peer connection. And ultimately, WebRTC is designed for low latency, extremely low latency. It's encrypted by default, peer-to-peer media and data. Everyone forgets about data. Like one of the biggest parts of WebRTC is the data channel. And it's got huge, huge benefits, but people forget to talk about it. NAT busting. So I think there's a stat which says like 90% of WebRTC sessions go from a client to a server now because we all talk to like an SFU. And Google Meet and Teams, etc., all use SFUs. But at its very core, you can talk to someone else that's behind a different firewall, behind a different NAT. So it's designed to be able to bust through that NAT using ICE. And it's made up of many, many different IETF specifications. So getting on to the topic of today, when you're talking to your clone pretty much understands you, right? Like if I was talking to someone else that's called Dan Jenkins, he would know exactly what I was thinking. And it would look something like this. No? Okay. libWebRTC is magic. WebRTC is magic. But yes, libWebRTC is a bit of a pain. We've heard it mentioned a couple of times today. It's absolutely huge. And to actually get going with libWebRTC, you have to go through a load of hoops to be able to download it in the right way and then to be able to compile it. It's a massive pain in the rear. But the key thing to remember is that libWebRTC doesn't equal WebRTC. If you go to WebRTC.org, you read about libWebRTC, but it's not true. WebRTC is a set of specifications. libWebRTC is just one of those implementations. So it's 2023, and we have loads of options now. So we've got something called PyOn, which is written in Go. We've got WebRTC Rust. We've got a new Elixir WebRTC implementation. We've got AIORTC in Python. The pipe team have some Java stuff that's open source, and then we've got libdatachannel. There are others as well. They're all variants of the same thing. Spiderman in many, many, many different forms created by Bing. So now you've got loads of flexibility, and you can choose the right tool for the right job in the language that's right for the right job. And this is great. But remember, with great power comes great responsibility. If you're not careful, you're going to fall. Can anyone see what's wrong with this image? Spiderman. I told Bing I wanted to create a picture of Spiderman falling in New York between skyscrapers with his arms out. I mean, Bing kind of got it right. DALL-E got it kind of right. There's an arm missing. And if you look in some of the pictures, Spider-Man's got 6 fingers a lot of the time. So yeah, all those things that you take for granted because libWebRTC dealt with it, the browsers dealt with it, are now your responsibility because you're implementing your API, talking to PyOn, Elixir, whatever, right? It's exciting, but it's also dangerous, right? So we use PyOn at Everycast Labs, and it's part of our Broadcast Bridge product alongside Janus and GStreamer. And we are very guilty of falling. So this is my tale of how even I, after over 10 years of working with WebRTC, fell hard. So let's take things back to basics a little bit. I'm 7 minutes in. I'm already on slide 46. Like, this is going really, really well. So let's take it back to basics. We fell into the basic example trap. Who has taken an example off of like a repo or a website and gone, this is really easy. And then you know, a day or two later you go, there's this edge case that I haven't thought about. There's real world examples that just don't work. So for us, that was getting media from Janus as an SFU into PyOn, and then getting that media from PyOn into GStreamer. And then from GStreamer, we then output it in loads of different formats depending on what the user wants, whether or not that's outputting to AppSync so that we can send it over to NDI, whether or not that's sending it over to the DeckLink plugin or the AJA plugin in GStreamer. And like, it worked. It was really cool. So you go and make a peer connection over to Janus using PyOn, and then you get the RTP out, and then you shove that into GStreamer. GStreamer does its magic, and then you chuck it out onto a sync, and it kind of just works. No, not at all. So the thing that we didn't implement was RTCP handling. So who remembers from earlier today what RTCP is? Dan, what is RTCP? Well, I mean, you obviously weren't listening to Lorenzo this morning. This is the benefit of being able to write my slide until the last minute. So RTCP provides out-of-band statistics and control information for an RTP session. So basically, it's the way that the browser or GStreamer or whatever, is taking in that media and it's going, I don't have something here. I've lost it somewhere before it got to me. I don't have it. Can you give it to me again? Right? That's the very basicness of RTCP. So what happens without RTCP handling? Well, we end up with something like this. Yeah, not pretty. So this is actually an output from NDI, I think. Yeah, doesn't look very pretty at all. It's not something you'd want to put up on screen. So you get media quality issues. And ultimately, there's no way for the receiver to say, I need help, send me help, do something. Bing thought this was what I wanted. I said, Spiderman shouting, I need help. Bing really likes Thor and Spider-Man. It gave me like 4 different options with Spider-Man and Thor. And then I told it, give me the same options but without Thor and a different character. And it just completely and utterly didn't understand what I was asking for. We don't have anything to fear from AI. It's not coming to steal your jobs. So what did I do about it? And this was the key issue, right? As a temporary hack, so that I could continue hacking stuff together to get it all working, I increased the number of keyframes that got sent down from Janus. Janus has a really nice API and config where you can say, go give me a keyframe every 1 second. This is bad, but I did it. Bad media, no problem. We're going to get a keyframe momentarily, and it's going to fix my picture, right? No. Well, I know it did fix my problem. It did. This is from WebRTC internals of another of a different receiver receiving exactly the same that Pion and GStreamer was. So yes, keyframes decoded should not look like that. Basically, it should be like, flat, 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 peak, flat, 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 peak. Keyframe means that we're sending way too much data and not relying on, how things are actually meant to work. Yeah, it actually worked really, really well. A little too well, because I kind of forgot that it was there. But yeah, obviously I was wrong. RTCP exists for a reason. My friend, Sahi, has written a very good article on media resilience in WebRTC and all of the different options that are available. So go take a read of his article. Maybe I should have done that before I implemented my stuff. So why did I get it so wrong? I've been working with WebRTC for, over 10 years now. How did I get it so wrong? Examples and the D word. The D word is documentation. Now, I'm not blaming Pion here. I'm the one that knows better. WebRTC is really difficult, right? WebRTC is built up of all of those individual component bits, and you forget about one of them, and it's going to come bite you in the arse. So WebRTC is made up of loads of bits, and it's really complex, and it's got so many moving parts. So where is the issue? I think this is the thing that actually made me go wrong. This is from the Pion website. It says, API Pion implements the WebRTC API. Spend more time building and less time learning on a new API. Absolutely fantastic, right? It's talking about the W3C API. So I all talked about this earlier. React Native WebRTC puts the W3C API on top of libWebRTC, just the way that we expect it to, because it's JavaScript and it's kind of pretending to be a browser, but not. So Pion's doing exactly the same thing, and WebRTC Rust has done the same thing, and lots of the other projects are kind of going down the same route. So I think, looking back on it, I expected too much magic from Pion. Let's take a very quick look at this example. This is RTX and NAC handling within RTCP, right? So I've sped this up quite a bit, and this is me kind of putting 10% packet loss on, and then trying to change it and failing. I'm going to go back in a second, restart it. But I put 10% packet loss on a Pion example that doesn't handle NACs. And hopefully, you'll see, so that's 1%. Oh, hold on, let me go back and start it again. So you can see it's kind of playing in the background, right? And then I add 10% and it just freezes. And it's not able to cope with it at all. And I turn it off and it starts playing again. I tried to take it down to 1%, but the network conditioner doesn't really understand that I changed it. And so it stayed at 10%. And this is me getting really confused with what's going on. This was me like 2 hours ago trying to record a video, and I was like, I'm not recording it again. So then we take it down to 1%, something more realistic, right? And you can see it's kind of pausing heavily, but you can still kind of like deal with it, but it's still pausing heavily. And this is the same, but with the bit of code that deals with NACs. So we're currently at 1% packet loss, and you can see no difference whatsoever. This is then me upping to 10%, the thing that caused complete and utter failure beforehand. And then this is me upping it to 30%. And when you watch it in real time, there is more stuttering, but it's completely and utterly watchable. So this is the code. This is the code that caused me so much. Well, actually, this isn't actually the code that caused so much problem. This is an example of something very, very similar. So what have we got here? So we're going to get the senders from our peer connection, and then we're going to process the RTCP. And then up there, we're saying, oh, right, process RTCP equals a function. And so we're reading from the sender, and we're not doing anything with it. Because as the comment says above, just reading it makes stuff happen. You don't have to do anything with it as a user, but we have to read it. It's not a magical thing that gets started for us. Would I have had to do any of this in JavaScript? No. I got complacent. I saw code that looked like this in the examples. So this is actually from a receiver, not a sender. And we're receiving our RTP, and then we're going to write a picture loss indication back every 3 seconds. And this is actually some of the code that I ended up using, as well as abusing Janice's kind ability to be able to say, send a keyframe. Yeah, send a PLI every 3 seconds. But yeah, this is an example code. This isn't production quality code, but examples are how we learn, especially when documentation is a little bit funny, because documentation is funny for Golang projects, because you're just meant to go to, the module and see loads of, function calls and like, how do they actually work together? That's where examples come in. So yeah, WebRTC is by definition a group of other specifications. We've got ICE, DTLS, RTCP, RTP, and that's only naming a couple. There's a load of others that kind of go into the whole thing. This means that any of these could cause you a headache because you're implementing it, right? You're saying, go create me some RTP, send it, right? You're now having to deal with, RTP header numbers and everything else. You've got to understand what this is doing because libWebRTC isn't just, magically doing it for you. We've got people like Lorenzo in the crowd that, handle this stuff day on day because SFUs have to handle this day by day. But us client developers, we don't have to deal with this stuff usually, but it's really powerful that we can, and I'm really happy that we can. But at the same time, Uncle Ben reminds us that, that it's difficult. So yeah, we've got RTP, codec, simulcast, SVC, RTP extensions, buffering, et cetera, et cetera. The list goes on. WebRTC can be really, really daunting, but it can also be really powerful. And now we've got the flexibility to be able to choose our client library, and that's a huge win. But yeah, like I say, you need to understand the core parts of WebRTC, and for us, that was RTC, that was properly handling RTCP. I mean, in your app, if you went and did it, you still need to handle RTCP too. Always handle RTCP. That's what I learned from this. Don't leave it to, I'll come back to it once I've got everything working. Don't leave it for another day. Interop is really hard, but I love that we now have it. So a world of libWebRTC only is a pretty dull one. Chad Hart has been following these trends for ages about which new libraries are kind of popular, etc. So take a look at that link as well. More choice is only a good thing, but remember, think of Uncle Ben. With great power comes great responsibility. And thank you very much.
Thank you very much. All right, and now time for a question. Like you handled that amount of slides really well, so we have some time left. Are there any questions?
Hey, Dan. Let me play devil's advocate a little bit. So as someone who also has to deal with a lot of client-side issues, do you sometimes think, like, wouldn't it be easier if we all use the same damn thing? Instead of, Firefox this, Safari that.
I mean, ultimately, yeah, like you say. So Firefox is using parts of LibWebRTC. Chrome is using LibWebRTC. Safari is using LibWebRTC. What if we all just, built libraries on top of LibWebRTC? And I think this would be amazing. However, that requires certain companies giving up control that they currently have, and actually answering questions and issues and accepting requests that in a timely fashion. But I mean, pigs don't fly, right? So yes, it would be absolutely lovely, but it's not going to happen, is it? It would be nice.
It isn't. It is. Great talk, Dan.
All right. Any other questions? Or stories?
Or stories.
Okay. Well, thank you very much.
Thank you.
Let's give another round of applause. Well done.